In this video, we're going to take a look at how to classify some basic types of chemical reactions. By doing that, you'll be able not only to tell me what a chemical reaction is, but also you'll generally be able to predict what the products of that chemical reaction are. And so we're going to put our reaction types into two big bins, the idea of a redox reaction and a non-redox reaction. And we'll work on classifying those separately. And then we'll break ourselves down just a little bit further into a couple of important types. One of them is combustion under redox, and one of them is single displacement. And under the non-redox, the most important things we'll look at are what's called double displacement, and also acid-base. So those are the major types we're going to take a look at in this particular video. There are more, but this will get us through a lot. So let's start with redox reactions. Redox reactions are actually more complicated than what I'm going to present here. This is the sort of get you through what you need for the first part of Gen Chem. We'll go into them in much more gory detail later. But to get oriented to redox reactions, the rule is to follow the charge. And when I say a charge in this case, let's go with usually the metal. The proper term is the idea of what's called a redox state or an oxidation state, but this will get you through about 75% of what you need to know overall and about 100% of what you need to know in this class. So we'll go ahead and stick with this. Here's a couple examples of redox reactions, and we'll start simple. Let's take a sodium metal and let's react it with silver acetate. If I use my solubility rules properly, like you've seen in another video, sodium is its element form, so it's going to be a solid, and silver acetate is an ionic compound that would be aqueous. The products that I'm going to get are sodium acetate, also aqueous, and silver metal. I can tell this is a redox reaction because if I look at it, silver is a +1 in silver acetate, and when I'm in my elemental form, it's 0. Similarly, sodium starts out as 0. If it's just the element from the periodic table, it's always 0. And in this ionic compound, it's +1. So the rule is that a charge change equals redox. This one was very obvious because it's a metal. Here's a couple of less obvious examples. All right, so let's look at these two different examples that you notice the problem is that there's no metals. And so I told you to follow the charge, usually metal. Sometimes you don't get that luxury. But what I want you to notice is that this one right here is one reactant makes 2+ products. And that's what we call a decomposition reaction. And then this one right here is CXHY plus O2 makes CO2 plus water. This thing right here is an example of what we call a hydrocarbon. A hydrocarbon contains carbons, hydrogens, and maybe oxygens. If a compound like that reacts with oxygen, that is a reaction type called combustion. And if you remember correctly, combustion from our first slide is a redox type. This type up here, where sodium reacts with silver acetate, is what we call single displacement. What you notice is that metals switch places. When you see metals switch places, you have single displacement. And we obviously showed that that was a redox reaction. So combustion and single displacement are our two types. Another one that is also a type that I didn't talk about in the first slide is something like this, where sodium plus chlorine makes sodium chloride. This is an example of 2+ reactants make one product, and that reaction type is called synthesis. What am I doing? I'm putting two things together. I'm slamming them together. I'm synthesizing them to make something new. Synthesis reactions in this category are also redox. Why? These are elements 0 and 0. This is +1. This is -1. There was a charge change. So for redox, you want to think about these general characteristics, that a charge change equals redox. And then there's these three subtypes: combustion, single displacement, and synthesis. You want to practice identifying those. So we got the hard part out of the way. We looked at the redox reactions and trying to figure out when charges changed and when they didn't. So if redox involves changing of charge, non-redox involves not changing charges. And there's two subtypes that we're going to look at. So I'm going to give you two examples. In our first example here, we have two ionic compounds. So let's note that there are two ionic compounds: sodium chloride and lead 2 nitrate. And you notice that between the reactant side and the product side, what has happened is that the ions have switched places. And they don't just switch places without paying attention to proper chemical formulas, right? This is still PbCl2 over here because lead is a 2+ and chloride is a 1-. Lead is a 2+ and nitrate is a 1-. So I have to pay attention. I have to predict carefully what's going to happen, which we'll talk about in another video. But what I want you to know is that this type of reaction is called double displacement. Why is it double displacement? Because two things are doubly displaced. They swap with one another, and that is a type of non-redox, is double displacement. Sometimes this is called double replacement. So if you hear that, or another word for it, right? So double replacement is a word. And last but not least is the wonderful funny word, metathesis. Those are all exactly the same reaction type. They are all switching ions. The charges do not change. It is not redox. We'll talk about those in more detail in another video. Here's one more subtype of that, though. And I'm going to take HCl and NaOH, and I'm going to make H2O and NaCl. When I switch those two ions, I notice that one of the ions is a proton, is H+, and the name for H+ is proton. And when I do that, I make water. So basically what I see is one of the cations is H+, one product is water. This type of a reaction is called acid-base. And what happens is you're swapping protons. An acid-base reaction we'll go into much more detail about in another class. An acid-base reaction is not a redox reaction. Why? Because it's the same switching idea. If anybody's ever done square dance, right? This is a do-si-do almost, except that you end up in the other place. Or you go on a double date with somebody and you guys don't go home with the same person, right? That's the way that double displacement works. It's still non-redox. So at this point, you know how to identify a redox reaction. You know how to tell me whether it's single displacement or combustion or synthesis or decomposition. You can distinguish between that and a non-redox reaction. And you can tell me whether a non-redox reaction is double displacement or acid-base. Classifications are important, so practice identifying. Every time you see and balance a chemical equation, try to classify it too.